So today our discussion will be from prism and the total internal reflection. Well, prism is a wedge-shaped body and it has got reflecting and refracting edge. However, reflection is very less, but refraction is maximum. So if we see the front face of the prism, it is basically an equilateral triangle with the angle of prism 60 degrees. So in prism, we have to discuss how refraction takes place. The incident light, first of all, falls on one of the face. It gets refracted within the prism and it bends. Then that refracted light comes out from the other end and that will be known as the emergent ray. So these facts we have to go through in the prism, and if the prism angle is A, then the refractive index can be estimated by sine A plus D divided by 2 divided by sine A over 2. That is what is the refractive index for the material of prism. It can be a quartz prism or a glass prism. Moreover, in prism we have to go through with the different definitions, like what is dispersion. Dispersion is basically the splitting of white light into 7 colors. So we send the light from one end, and when it emerges out from the other face, the spectrum is taken on the screen, and we find that that particular spectrum is made up of 7 colors. Normally that is taken as Vibgyor: violet, indigo, blue. Then it is green, red, orange, and yellow. Beyond red, it should be infrared, and earlier to that is violet, it should be ultraviolet. Ultraviolet and infrared regions are invisible to the normal eye. So now we come to the main concept. So first of all, our discussion is from the refraction by prism. So we come to the definition of prism. It is a homogeneous transparent medium enclosed by two plane surfaces inclined at an angle. These surfaces are called the refracting surfaces, and the angle between them is called the refracting angle or the angle of prism. As I have explained earlier, the front face looks like an equilateral triangle. So refracting angle or the angle of prism is same. Normally it is found to be 60 degrees. Now we come towards the diagram. That is, the figure of the prism is being indicated. Incident ray is passing on the one face. It gets refracted. Refraction takes place within the glass prism. Then this refracted ray of light emerges out from the other side. So there we have mentioned emergent ray. Now, if we extend the incident ray forward and emergent ray backward, then the angle between the extended incident ray and the backward emergent ray is called the angle of deviation. A stands for angle of prism, and a dotted line is indicated which is perpendicular to the incident ray of light. So angle between the normal and the incident ray is known as the angle of incidence. Delta is representing the angle of deviation and I2 is representing the angle of emergence. So we proceed forward. Now we come towards angle of deviation. Angle between the incident ray and the emergent ray is called the angle of deviation. This I have just now explained. Now we come towards the minimum deviation, that is where we find the angle will become less. For a given prism, the angle of deviation depends upon the angle of incidence of light ray or the incident ray falling on the prism. It is seen from the curve that as an angle of incidence I increases, the angle of deviation first decreases, becomes minimum for a particular angle of incidence, and then again increases. Therefore, for one and only one particular angle of incidence, the prism produces minimum deviation. So what is the necessary condition for the minimum deviation? that just for one particular angle of incidence, the deviation produced will be minimum. So, formula for the refractive index of the prism, that is given by function mu is equal to sine A plus D over 2 divided by sine A over 2, where A is the angle of prism, and for mu we can have two representations. Sometimes we represent it by n or sometimes by mu. So we can have both the symbols. So at a time we will use one symbol out of the two. Now this is the formula shown, that is refractive index is sine I over sine R, where I is the angle of incidence and R is the angle of refraction. So as I have suggested, sine A plus delta M. Delta M means minimum deviation. So sine A plus delta M divided by 2, and in the denominator it is sine A over 2. And I have marked here, that is n or mu is the same thing. They are indicating the refractive index of the medium. So basically refractive index means that is indicating the magnitude of deviation. That is what the meaning of refractive index. And in the adjoining figure, a graph is indicated between I and delta. So what we are finding, that as angle of incidence is increasing, the angle of deviation is first of all increasing, and then further we find it becomes minimum at a certain point, and after that point again when I is increasing, the deviation is further increasing. Now we come towards, that is the where A is the prism angle and delta M is the minimum deviation. When prism is thin, then we make certain variations, that is the value of A will be small. It should be less than equal to 10 degrees, and delta M or minimum deviation will be calculated by function n minus 1 or mu minus 1 into A. N and mu are the same thing. Both are representing the refractive index of the medium, that is refractive index of the glass prism. Now condition for the maximum deviation, that is I1 or I2 must be 90 degrees as it was indicated in the figure of prism. Now we come towards angular dispersion for prism. What is basically the angular dispersion? White light splits into its constituent colors on passing through the prism. This I have already explained, that whenever white light is passed in the prism, it emerges out in the form of a spectrum that is made up of 7 colors. They are obtained on the screen on the other side where the emergent rays comes out. And this spectrum is generally designated by wave gear: violet, indigo, blue, with gear, green, yellow, orange, and red. These are the 7 colors. Beyond red will be infrared, and before violet it should be ultraviolet, and both are invisible regions. And when we study the wavelength or the frequencies, we find that from violet to red, the wavelengths increase, but the frequencies decrease. So violet has the minimum wavelength and red has got the maximum wavelength, and other colors have the intermediate values. So now once more I will review that white light splits into its constituent colors on passing through the prism. This is known as dispersion. The angle between the emergent rays of any two colors is called angular dispersion between those colors. If deviation angle for violet and red are delta V and delta R respectively, then angular dispersion means the angle between the violet and the red light. So we further proceed, that is theta angle, angular dispersion, that is given by delta V minus delta R, or we will say delta R is equal to mu R minus 1 or NR minus 1 into A. A stands for angle of prism and NR stands for refractive index for the red light. Then we write delta V, that is the deviation for the violet light, and it can be represented as that is NV, that is the refractive index for the violet minus 1 into A. So NV stands for refractive index of the violet light and A stands for the angle of prism. Now if we wanted to find theta, it should be delta V minus delta R. So we compute the two values, that is for delta V and for delta R we compute the values, and our final result will become that is NV minus NR into A. NV stands for refractive index of the violet light minus the refractive index of the red light. A stands for the angle of prism. So theta represents the angular deviation, and this deviation is between the violet and the red light. So angle between the two emergent colors will be angular dispersion.